Today we're starting on Chapter 3 on increasing and decreasing functions. These are tools that we're going to use to be able to discuss and analyze things like revenue, cost, and profit, and whatever else you have. A couple of tips for the section. One is that as you go to an example, or even maybe not a real world type example, try to think of this in terms of a business. So what you might do is concoct in your mind some kind of business that you'd like to keep in mind. Would you like to sell TVs, for example? I just picked that one up. Or maybe you'd like to sell computers or pens or whatever. Just keep one particular thing in mind as your business. And we're going to be talking about increasing and decreasing functions, critical numbers, increasing and decreasing functions to solve some real-life problems. From the second and the third, you might notice that we're going to be talking about derivatives. Increasing means the slope is positive, decreasing, the slope is negative. Critical numbers, that's where you go from increasing to decreasing, or vice versa, in general. Not always, but usually. So here's a color-coded one: increasing red, increasing green, decreasing red. So, a comment or two on this one. This looks a little bit intimidating because of the math symbols here. So let's try to simplify this just a little bit. A couple of things to remember. This part right here, that might be the first confusing part. First of all, notice in both of these statements, it's saying the same thing. What is it actually saying? Well, visually, what it's saying is you're going from x sub 1 to x sub 2. Basically, you're going from something that's on the left to something that's further on the right. That's what it's saying. So as you're scanning it, as you usually would because you're doing it like you would with reading, as you go from the first x value to the second x value, what's happening to the y values? These are just y values. And this says that as you go from the first one to the second one is bigger. Another way of looking at that is, here's your first y value, and the second y value is going to be up here somewhere. If that's the case, then your function f, or whatever you're calling it, is increasing. And on the other hand, if as you scan from left to right, the y values are going from, there's your first y value. If the next y value is lower on the graph, then your function is decreasing. It's just like that. Here's a picture. First one shows some function decreasing, and then stays the same, and increasing. One way you might prefer to think of this, or might find easiest to remember, is that if this represents your annual salary, how much you're getting paid this year, and next year you get this amount, what's happening to your salary? Your salary is decreasing. This might be the timeline right here. Here's this year, here's next year, here's the year after that. And going from this year to this year, your salary hasn't changed. It's constant. Going from this year to this year. Your salary is going up. It's increasing. That's all this really represents. Next, of course, we get to the derivative. And the derivative of a function actually makes things even easier. You don't have to graph it. Take the function, get the derivative, and to see whether it's increasing or decreasing or staying the same, check out three things. First of all, take the derivative somewhere in that interval. You're going from a value to a b value in x's. Excuse me. What kinds of derivatives do you have? If your derivatives are all positive in that interval, then your function is increasing. If in going from a to b, your derivative is negative, then your function itself, whatever that is, revenue, cost, profit, whatever it is decreasing. If your derivative is zero, that means, remember, derivatives mean change usually, and the derivative being zero means it's not changing. And that means your original function is constant. It's not changing. So here's a function for us to play with. We've got f of x equals x squared. And it says show that it's decreasing on the open interval, decreasing here, and increasing there. Well, let's jump to the derivative right away. It's easy to find the derivative of x squared, that's why that was chosen. Bring that 2 out front, reduce the 2 by 1. Your derivative is 2x. So what kind of derivative values do you have from negative infinity to 0? What is the derivative looking like? Well, pick something. Play with this. Let's say negative 17. Pick a number back there. Any number at all. What happens? 2 times that number, what do we get? We get a negative 34. All we care about, though, is just the negative part. If it's negative, the function is decreasing. It's as simple as that. Take the derivative, pick a test number in there, anything at all. Put it in for the x, see whether you get a positive value or a negative value. If it's positive, it's increasing. If it's negative like this one, it's decreasing. That's all there is to it. Just taking the derivative, picking a test number inside that interval, and see whether you've got a positive or negative or zero derivative. Negative, it's decreasing. 0, constant, positive, increasing. And there's a picture of our function. That should look very familiar to you. It's a parabola, a standard parabola, one with a vertex that goes through the origin, and you can see where it's increasing and decreasing. Remember, the y values are what you look at to decide whether a function is increasing or decreasing. Critical numbers. Ooh, that sounds dangerous. Well, you don't want to go into a critical condition, right? But critical numbers themselves can actually be helpful. So let's take a look. You got 2 intervals, one where it's decreasing, one where it's increasing. Somewhere in there, something's changed with the derivative. The derivative In this case, the derivative was negative, and somewhere this started going positive. So you're asked to decide where those intervals are. Where is it increasing? Where is it decreasing? That's the question. Here's a picture you can look at that gives you an idea of what we're talking about. The first part over here, as you're going along this part of the graph, it's going upward. That means the slope is positive. That means it's increasing. Over here, the slope is negative. That means the slope is negative, and the function itself is decreasing. Remember, it's all about the y values. From here to here, the y values are getting smaller. From here to here, the y values are getting bigger. At the top is where it goes from increasing to decreasing. There is a critical point. It goes from decreasing or increasing to decreasing. Over on this one, it goes from decreasing to increasing at a particular point. So this is a critical number. To find out where that is, you've got something simple to do. First, take that function, take its derivative. Look for two things. Where is it 0? Set your function equal to 0. Find out what this c value is. If it's 0, or if you get something that's undefined, the two possibilities. If a critical number or the function is, the derivative is 0 or the derivative is undefined. Those will give you your critical numbers. That's what you're interested in. Those are important pieces of your puzzle as a business. So here are the steps. Find the derivative first. Find the critical numbers. Try setting the derivative equal to 0. Find out what numbers are critical numbers. Also look for any places where that derivative is undefined. Those will give you other critical numbers. These critical numbers if you look at a number line and you've got some critical numbers in here, say that's critical number 1, critical number 2, maybe critical number 3. One very simple thing that these numbers do is split the number line into several different sections. You've got numbers out here, you've got numbers in here, you've got numbers in between there, and you've got numbers out there. 3 critical numbers give you 4 different areas of the number line, 3 different sets of numbers. Once you get these numbers, these critical numbers, all you have to do is test. Pick any number between these 2 critical numbers, any number at all, and put it into your derivative. Is that number positive, negative, or 0? That's going to tell you whether it's increasing or decreasing or constant all the way through that interval. It doesn't matter what number you pick in that interval, it's going to tell you what's happening with all those places in that interval. You go over here between C2 and C3, critical number 2, critical number 3. Pick any number that's convenient or some number that attracts you for whatever reason. Put that into your derivative. See whether you get a positive, a negative, or a 0 for your derivative in that interval. All it takes is just one check. See whether it's increasing or decreasing on each interval. So these critical numbers, split the number line into several sections, go to each one of those sections, pick any number in that area, not at the edge, somewhere in the middle. Put that into the derivative, see whether you get a positive, negative, or 0. It'll tell you whether it's increasing, decreasing, constant. Next, find the open intervals on which f of x, and there's your function. I'm not going to read it for you. Where is it increasing or decreasing? Where do you think you'd start? Take the derivative, because the derivative in different sections on the number line is going to tell you whether it's increasing or decreasing and where those endpoints are. So you differentiate it, and just in case you're even the slightest bit confused, remember that okay, I'm going to typo here. Somehow one got in here that shouldn't have. It should be 2/3, that comes from the exponent. The new exponent becomes 1 less than that, or negative 1/3. So I'll have to fix that in my master here. Slide 21. Okay. Now we've got our derivative fixed. Remember the chain rule. Taking the derivative of a function that has an inside function and an outside function. Outside function 2/3, subtract 1 from the 2/3, there's your negative 1/3. Leave this alone at the beginning. Once you've written this out for the outside function, take the derivative of the inside function. There you go, 2x. A little bit of a cleanup there, because remember this 2 that we've got here is in the numerator. We've got another 2 in the numerator here. That's why we've got 4 and our x in the numerator, giving us 4x. This 3 is in the denominator, good. And because this has a negative 1/3, that goes in the denominator, and there's your exponent. Now, what you can see is you get 3 critical numbers. So where do they come from? Sneak back here. If you set that equal to 0, so here's our derivative from this. Set that for x over 3 times x squared minus 4 to the 1/3 equal to 0. Now you're looking for a couple of different things. First of all, you're looking for what would make it equal to 0? Well, if this x right here is 0, then the derivative is going to be 0. So x equals 0 is a critical point. Notice here, if this x squared minus 4 equals 0, this is going to be undefined. And that means by factoring this, we can find out what those extra critical numbers are. Set that equal to 0 because that would make this fraction undefined. Get the 2 and negative 2. There are your critical numbers. Now what did I say a little bit ago? Those critical numbers split up the number line. So what we've done, here's our number line. Say this is 0, 1, 2, 3, 4, and so on. Three critical numbers. One's here, and one's here. What does that do? That splits the number line into 4 sections. You got part of the number line over here. Sorry about the drawing. There's one section of the number line from one critical point or end to the other. Here's another section of the number line, and here's another section of the number line, and the rest of the number line. So 4 different sections. 1, 2, 3, 4. What do we do next? The next part is pretty easy. You've already got your derivative. Remember your derivative we already have. Take any number here that you like. So for example, maybe you want to use this and you want to check this out. This is negative 3. It's going to be your test. You'll take that negative 3, put it in your derivative, and see what you get. All you care is, are you getting a positive value or are you getting a negative value? It doesn't matter what the magnitude is, just whether it's positive or negative. If it's positive, that means this function is going to be increasing here. If it's negative, then the function is going to be decreasing in this interval. Next, pick a point in this second interval. An easy point here would be pick the negative 1. Take that negative 1, put that one in the derivative. See if you get something that's positive or negative. Positive means increasing there, negative means it's increasing. And that means at any point here, you're going to get the same positive or negative value. So all you have to do is pick anything in that interval, and it's going to tell you something about the whole interval. Then you'll go to the third interval. An easy one to pick here might be the number 1. So you take your derivative, put a 1 in there, and all you care about is, are you getting a positive number? That means it's increasing. If you get a negative result for your derivative, it's decreasing all across that interval. The y values are increasing or decreasing just because of that simple test on the derivative. Then you go to the fourth interval, and you have quite a few numbers to pick from here. Of course, you can pick numbers in between. It doesn't make any difference. Maybe you want to pick a 5, for example. See, this is 2, 3, 4, 5. Maybe you want to pick a 5. Here's your test for this one. Take your derivative, put a 5 in. Is it positive or negative. That's all you need to tell whether it's increasing or decreasing. Very simple. A bunch of guidelines that are different to you, so make a note. Make a special note. Put it maybe on index cards and carry it with you for a few days, or carry it with you for longer than a few days. So those critical numbers split the number line into 4 different sections, as I said. All you have to do is pick any test value you like. So here are the intervals up here. You're going to pick something that's in here. See whether that gives you a derivative that's positive, negative, or 0. Since putting -3 into our derivative gives a negative value, that means everywhere from here to here, your function is decreasing. Similarly, for all the rest. You don't have to pick the -1. You can pick anything between these 2 points. Anything at all. Put it in your derivative, see if you get a positive or a negative answer. And then I'll tell you whether it's increasing or decreasing. Third section, pick anything you like. If you wanted, you could put 1.5 in there instead. You'd still get the same result, and you can still find out whether it's increasing or decreasing just by the sign of that derivative in that interval. And the fourth interval, pick anything you like. If you want to, you can pick a 13 or 130. It doesn't matter. Put it into your derivative to see whether it's positive, negative, or 0. And that tells you whether the function itself, that's f is increasing, f is decreasing, f is increasing, f is decreasing. Just take each interval, get a test point in each one, and there you go. So there's a picture of what your graph looks like and what's happening in each of those 4 intervals. The other direction is not true. It could be increasing even though the derivative is not positive at every point in the interval. Here's a quick one. We've got a function to use here. How are we going to find whether it's increasing or not? First, we'll take the derivative, and then we find where it's 0 or undefined. It'll give you your critical numbers. Those critical numbers will split the number line. Into sections or intervals. Test each interval. Oops. You can choose any point you want in the interval. Any point at all. Is your derivative positive or negative. If your derivative from your test point is positive, your function is decreasing. Remember, that's the function itself. If the derivative in that interval is negative, then your function, did it again. I'm not sure why I'm doing that. If your derivative is negative, then the function itself is decreasing. You only have one critical number. That means your number line is only split into two parts. So this critical number right here is going to split up your number line. Say this 0. There's your critical number. You got two sections. Pick your favorite number back here, whatever that number is. Put that number into the derivative and see whether you got a positive or a negative number. Take some other number out here. Put that into your derivative. You get a positive or negative. That's going to tell you whether it's increasing or decreasing. It's as simple as that. Notice 1 is the only point that makes it 0, and there are no points that make it undefined. So you get no points, no critical points from being undefined. Those are your test intervals. Pick any point you like. The person who made these slides or whoever was in charge. Pick the 0 for the first one. Pick the 2 for the second one. Just put that number into the derivative. This turned out to be positive, so it was increasing. Put that 2 into the derivative. It was also positive, so it was increasing there. And those are the only two intervals we've got. Up to a 1 and after a 1. So it's increasing everywhere. Finally, an application. Talking about profit. Tell me that isn't important for your business. Here are the functions for the cost and the revenue. You want to find out when the profit is increasing. So what do? Profit function is profit equals revenue minus cost. That's something you need to keep in mind all the time, or derive it each time. You've got the cost and the revenue functions, so just put those into R and C. There's your profit function. The top one is how we get it, and the second line is after some simplification. So there's your profit function. You could put this as P of X, because your profit is going to be dependent on how many items you sell, and that's the X, the demand. So what's the interval? So differentiate it. There's our derivative. Notice that it's not going to be undefined regardless of what X you pick. So undefined is not going to give you a critical point, but if we set this equal to 0, 43. Set that equal to 0. Another small typo for me. Set that equal to 0. And solve for x. And what you've got is 3,000 games. So what's 3,000 games? 3,000 games is your critical point. Remember just a moment ago, that's where the derivative was 0. 3,000 games. Something happens at 3,000 games. On the first interval, up to 3,000, if you put any of those numbers in for the derivative, you get a positive number. That means your profit is increasing. Put any number from 3,000 to 6,000, and you'll find the derivative is negative. That means the profit is decreasing. Now, you might not have given it a thought, but why those intervals? Because just a few minutes ago I was saying, take the whole number line. And your critical number split up the whole number line. Why are there no negative numbers? That's because you can't sell a negative 13 games. You could sell 0 games, but not a negative 13 games. So this first interval doesn't even start until you get to 0 games. The 3,000, of course, is the critical point, and 3,000 is where your second interval starts, and it only goes to 6,000. Here's your picture. What happens at 6,000? That's as many games as you can produce. After 6,000, you don't have any profit anymore. That's why you stop at 6,000. You start at 0 because you can't sell less than 0 games. And you don't want to sell more than 6,000 because then you'd be losing money. And that is the story for increasing and decreasing functions. So you might want to look over that again and send me any questions you got. And with that, we'll send you out. That's 3.1, and I'll see you in class. Bye-bye.